Let's now see how to read data from the push button, and more specifically, how to know when we have pressed on the button, so the exact moment when we have pressed on the button. This is something you should already know how to do as per the prerequisites of the course, but I'm still going to do it quickly as a recap. Also, we will debounce the button. So, first of all, what you're gonna do is to create a define here, button pin. So define our constant int, and so the pin is number 7. And then if you want to initialize the push button, you do pin mode with button pin and then input. So the push button is initialized. Now if you want to read from the push button, you're gonna do digital read button pin, and this is gonna return you a byte, okay, that is high or that is low. So for example, byte state is equal to digital read button pin. Now if we want to check if we have pressed on the push button, what we need to do is we need to save the previous state. So we need to read the state, save the previous state, and then read again and check if we have something different, okay? So I'm gonna add here byte previous button state, and I'm simply going to initialize that here to the current state of the button just after we initialize it. So that will be the first state of the push button. And so now what we need to do in the void loop is to read the push button again with digital read and then compare to the previous button state and see if we have something different. But what I'm also going to do is I'm going to debounce the push button, because if we just compare the previous and the current state, what's going to happen is we're going to have the bounce mechanism, so the physical bounce of the button, and this will give us some wrong measurements. Okay, so we need to debounce the button to make sure that when we actually press, we get just one press on the code and not multiple presses because the button is bouncing. So to do that, I'm going to create two new variables here, unsigned long last time button pressed is equal to, so let's initialize to millis or to 0, it doesn't matter, and then unsigned long, let's say button debounce is equal to, and let's put 50 milliseconds. So what we're gonna do here, basically we're gonna first in the void loop get the time, so unsigned long time now is equal to millis. And then we're gonna do if time now minus last time the button has been pressed. If this is greater or equal than the button debounce duration here, then we can enter this if. So we will see that when the state of the button changes, we're gonna update the last time the button was pressed to the current time. And so that the next time we enter the void loop, we're gonna check the condition, so time now minus last time the button has been pressed, and if this is lower than the delay, so basically if this is lower than 50 milliseconds, then we are not going to read the state again. So basically we are going to ignore the button for 50 milliseconds every time the button has been pressed. So we don't read all the bounces of the button. So now if enough time has passed, what we can do is do byte button state, so the current one is equal to digital read with button pin, like this. We read the button state and then we do if button state is different from the previous button state. In that case, we know that the state has changed, and what we can do is to now update the last time the button pressed. So actually let's name it different, last time button changed, okay, because it's not pressed here, it's just changed, because if we are here it could be pressed or released. So I'm just gonna use changed, which is for both. Okay, so last time the button has changed is actually time now, okay, because that's what just happened. And also I'm gonna update the previous button state, which is now the current button state. And so the next time we enter the void loop, we're gonna first check if enough time has passed since the last time button changed, and we're only going to enter this if again after 50 milliseconds. And then, well, when we are here in the code, we know that the button state has changed. So to know if the button has actually been pressed or released, we do if button state is equal to high. In our case, because we have a pull down resistor, this means that the button has been pressed. And if it's low, it means the button has been released. So here we could do, so let's actually do serial.begin. So here we use serial to debug and serial.println, let's say button has been pressed. So when we enter this if, we know that the button has been pressed, so just pressed, and we don't have any bounce because the next time we're gonna read the button is 50 milliseconds later. So let's upload the code, and actually we have an error. Why do I have this error? You can see can't open device because I have simply not plugged my Arduino to the Raspberry Pi or to the computer if you're using your normal computer. And now I check tools, okay, upload, and down uploading, I'm gonna open the serial monitor, make sure the baud rate is correct, and I'm gonna press on the push button. Button has been pressed. Okay, I press again, and you can see every time I press, so I press again, button has been pressed. One more time, and well, the code is working. So this is the structure that you're gonna use often to know when you have pressed or released on a push button and with the debounce mechanism.